Welcome back. Looking for another identity problem to do? Here we go. Trigonometric identities show that or prove that cos3 theta is the same as 4 cos cube theta minus 3 cos theta. The examiners love this sort of question because it's not one of the formulae that's on your formula sheet or formula booklet, but it's a nice one because it's several lines of working and you get to see some of the other identities that you can substitute in. So I'm going to work through that and then I'm going to do part B where it says hence use that result. That's effectively what the hence means, isn't it? I just filled in the use that result because that's what hence means. Solve the equation with this. So I'm going to do that in 2 steps. I'm just going to take a step back in case you want to do a screenshot. And if you want, you can just work through it, pause the video, see how you get on, then unpause it and see just how far along you managed to get. Hopefully all the way. So look, I'm going to start with the left hand side, which is cosine 3 theta. And the idea is I'm going to rewrite that as cosine 2 theta plus theta, because they've given you that hint, which is a bit of a shame. I think it takes the fun out of things when they tell you how to do it, but there you go. You're not going to complain, are you, if you do an exam? So if we use that, we're going to replace A and B with 2 theta plus theta, because that's how we get the 3 theta. You see, that's your starting point. Once you've got that done, you can then substitute into this. So here's going to be cosine 2 theta, then cosine theta, and then don't forget subtract sine 2 theta sine theta. Okay, and that's the first line done. Now, what next? It tells you this hint. Like I said, takes the fun out of it. But what you're supposed to be looking for is the fact that you've got 2 theta there, 2 theta there, but in your required solution, required answer, there's just theta. So what we've got to do is try and get the 2 theta down to theta, and that's generally your method of solving any equations or proving identities. You're looking to see what you need. You've got a mixture of 2 theta, theta. You've got to use an identity somewhere to make it all the same angle. Clear? Hope so. So we're going to use an identity here, and you've got a choice, haven't you? You've got a choice of which one to use. So either you can use this one, or this one. Okay? You've got a decision to make. Let's just go back and have a look at the answer again. That's all in terms of cosine. Yep. So the one you want is this one here, it's in terms of cosine. But don't panic. If you mistakenly use that one, you're still way round, okay? Because if you write down this, you can still replace sine squared A with 1 minus cos squared A. A little bit further on. This just gets you there more quickly. You wouldn't want to use this because it's a mixture, but same again, if for whatever reason you did use that, maybe it's the only one you remember because it's not on the formula sheet. Okay, if you did use that, again, you can just use this there and again get to that more quickly. All right. So 2 cosine squared theta minus 1. Part of the challenge is make sure you get the right letter. Okay, because all this is in terms of theta, so make sure we're using theta, not x or a or any other letter. Okay, and I'll just put in brackets there, just showing that this is the identity I've used, because all of that is multiplied by cosine theta. The brackets are important. This sine 2 theta, that's a lovely one because there's only one identity, isn't there? Okay, the identity for that is 2 sine theta cosine theta, and then multiplied by sine theta. I don't put brackets in there because it's not required. You could be if you wish, if you're trying to show that that's the identity you use in place, or for your notes, but I generally don't write brackets. I'll leave them there. They're there now, I'll leave them there, but I generally don't. Then we just expand this and simplify. So 2 cos cubed theta. It's nice when we get one of the cos cubes in place because it means we're going in the right direction. Subtract cos theta and then minus 2 sine squared theta cosine theta. Now what do we want? Well, we're nearly there. The good thing is they're all now theta and we just want theta, so that's that job done. But now this is in terms of sine and we want it in terms of cosine. So we've got to use the identity to replace sine squared theta with something. And of course that's going to be 1 minus cos squared theta. So here, write that again, 2 cos cubed theta minus cos theta, subtract 2, and then here we go, replace the sine squared theta with 1 minus cos squared theta. Brackets required this time because it's all of that multiplied by 2 and by cosine theta. Okay, let's go make a bit more space by scrolling down a little bit. Okay, I'm going to try and keep the answer there. Tell you what, I'm going to scroll all the way down and just move this bit down. Just so you can see what the final answer is that we're trying to get towards. Hopefully it's 2 more lines. So 2 cos cubed theta, sorry for the dodgy 0, or O I should say, 0 is a number, O is a letter, sorry for the dodgy O. Yeah, minus cosine theta, subtract, let's get this right, 2 times cos theta, and then subtract negative, so plus 2 times cosine cubed theta. Okay, you'll know you've got that bit wrong if it doesn't match up with that. Okay, because what we need is that and that to combine to make 4 cos cubed theta, which it does, that plus that. So if you'd made that negative by mistake, you'd see that they will cancel, and hopefully you'd adjust that problem by rewriting it. So 4 cos cubed theta, and then this and this you want to combine to make subtract 3 cos theta, which they do. So subtract 3 cosine theta, which is the right hand side, which is what you wanted. I would normally put equals right hand side underneath, but I've run out of room. Okay, I can do it there actually. Scroll down a little bit more. Equals right hand side as required. Okay, like that. A lovely question because of all the great identities that you get to put in place. So let's have a look at part B. So part B was hence solve. So hence means use this, and I've just recorded that again from the previous part of the question, just so that you don't have to go flicking back and forth through the screens again. So the final way of using that somehow. Now the obvious place I'm hoping for you to see is that we're going to place it there. Okay, so cosine 3 theta is there, isn't it? So without even reading the rest of the question, let's just do that now, shall we? So 2 multiplied by all of that. 4 cos cubed theta minus 3 cos theta. Right, that's that done. And then so we've got plus cos 2 theta plus 1 equals 0. What's it asking to do? Solve this equation given answers in this interval. So let's just make a note of that, shall we? A hint for you in exams. Now's the time to fiddle with your calculator, get it into radians mode before you go on, okay? Because when you do the solution, make sure it's in the right mode, and in the interval between 0 and pi, inclusive of 0 and pi. I generally ignore that bit. I sometimes use a graph to demonstrate why it's happening, but when solving it, okay, numerical methods, trial and improvements, no, let's do this as mathematicians always intended from the beginning, okay? When the first people rose out of, where they've come from, the sea, I don't know, some goo, millions and millions, I don't know, the whole evolution thing, but when man first started to think, walk, I'm sure somewhere along the lines they were thinking, let's do trigonometry without calculators. Yes, if one day technology should be so advanced that we need calculators, all mathematicians should just cast them aside and use just pencil and paper, chalk and slate, or whatever. Anyway, so I just rambled on a little bit, but those who know me best know that I don't like calculators unless it's for the final steps. Okay, when I simply cannot do it in my head. Let's expand this. 8 cos cubed theta minus 6 cos theta. That's not a nice looking theta, is it? Let's do that again. Plus, right. Now, get to this bit. It's an equation we're trying to solve. What we want to do, let me just fast forward a little bit. We want to end up with something like this. Cos theta equals something. So we can then use our beloved, trusted calculators to get a solution. Okay? But we've got cos 2 theta there, so we've got to deal with that. So with any equation, you've got to make sure all the angles are the same. So theta, that needs to be theta. So you've got to deal with this. Okay? And like before, you've got a choice. Which one do you want to use? And just show them again. Okay? The one that's circled is the one you want still. Okay? Circled loosely. Elliptical. That one's the one you're going to use because it's all in terms of cosine. Okay? Because the other thing is, when you're solving an equation, you want to make sure it's all the same trigonometric function. So either all tans, all sines, or all cosines. So here, replace that with 2 cos squared theta minus 1, and then plus 1 equals 0. Okay? Let's just simplify that a bit, shall we? So 8 cos cubed theta Put it in order, shall we, of the powers. Plus 2 cos squared theta minus 6 cos theta. Subtract 1 plus 1. Cancels, it equals 0. Right, so we should end up with that. Right now you're thinking, what? That's a cubic. I was solve one of those. It's an A-level exam. So sometimes things get difficult. Okay. Shock, horror. Yes. Yes, I remember the days as well when I was like, last millennium doing the A-levels. Okay, yes, last millennium. Okay. But yeah, things are hard when you're that age, aren't they? But you just got to know how to deal with it and always keep calm during the exam. Keep calm. It'll be all right. First thing to do is do not divide that by cosine theta. Factorise it. Okay. I'll tell you why if I remember. Okay, when I've done this bit. Factorise it. So this is 8 cos squared theta. So I just hesitated because I thought I could do something else as well. Plus 2 cos theta minus 6 equals 0. Okay. The thing is, cosine theta equals 0 is a solution, isn't it? So somewhere you have cosine theta equals 0 as a solution. If you divide it throughout, let me just show you. If you just did this, okay, you're going to lose track of the fact that cos theta equals 0 as a solution. That's why I recommend you don't divide. You just do. What you can do is divide that by a numerical value. Divide that by a value you know it's not going to be 0, like 2, for example. Let's just close that bracket off. So if you want to divide by 2, you could do, that's absolutely fine. So you'd have cosine theta. So if you divide all that by 2, that would be 4, wouldn't it? So 4 cos squared theta. That one would be just cos squared theta. So that's cos theta. And that would just be negative 3 cos theta. Okay, so you could do that. Yeah, no problem. Just don't divide that by cos theta. Okay. Running out of space. So if you don't mind, I'm just going to erase this line just a little bit. Okay. Just for the purposes of making it a little bit more presentable for you good people watching this video. And then we just go ahead with that. So now we've got a quadratic, which is less scary for some of you. Factorising is usually the way to go with these. Okay, so if you're tuning in and you're a Year 11 student or Year 10 student and you're thinking, wow, factorising is really hard, well, just wait till you get to these lovely things where you factorise with trigonometry. Now you know you've made it if you've managed to get this far. Well done, by the way, all of you. Well done if you're still watching this video and if you're doing A-level maths in Year 13. Not many people in the world can say that they've got to Year 13 A-level maths. Okay, so just make yourself feel special for just a few minutes. Okay, you are a unique, elite set of people that have managed to make it to Year 13 A-level maths. Okay, some people, a lot of people, most people don't even get this far. Okay, right, so let's see how we factorise that. Well, clearly there's going to be a 1 and a 3 and 4. I'm just going to take it, well, an experienced, not guess here, but I reckon it's going to be 4 cos theta theta and 3 there. 1. How do I know that? Because in my head I'm thinking 2, 2, 3, 1. It's not going to work out. 4 and the 3. I can make the. Doesn't matter. Just yeah, it's an experience thing. When you've done this so many times, you get the hang of it. Okay. So what I want to have plus 4 cos theta minus 3 cos theta to get that. And I want to have the negative 3, so that's all going to work in. So that's that. Okay. Next, we then write down that our solutions are either cosine theta equals 0, cosine theta, let's do it in order of simpleness, shall we? That one there, negative 1, or cosine theta is equal to this one, 3 over 4. Okay, in order of simpleness. And let's just remind ourselves what the interval is between 0 and pi, which is nice because it's a shorter domain, isn't it? So between 0 and pi. So cos theta equals 0. Theta equals, what is it? Pi over 2. Now use your calculator if you wish. I'm just going to draw a quick sketch of a cosine graph. Where can I squeeze that in? Here we go. There we go. So this there is pi over 2. That's 2 pi. That's pi. That's 3 pi over 2. So here, cosine theta equals 0, so you've got pi over 2. Use your trusted fellow companion if you wish to check, but it's that. Not this one, but that's 3 pi over 2, and the interval is in between 0 and pi. So just that one there. This one, so you can see from the graph, -1 there, so it's going to be just pi. That's the only one between. So I've actually got that's right on the edge, just right on the boundary of the interval, isn't it? And then this one, this is the time where I use my calculator because I can't do that one in my head, I just don't know. So radians road, yeah, inverse cosine of 3/4, 0.72. Let's just check. Give your answers in the interval. It doesn't say how to round it, does it? Okay, unless I've missed it somewhere. No, it doesn't say how to round it. So I normally go for 3 significant figures. Okay, 0.723. It's 0.72273, etc. But I'm going to go for 3 significant figures. There we go, 3 SF. Okay, and there you go. That's it. That's that lovely question done. If you feel the need to highlight your answers, you can do. Just trying to find solutions that are greater than that, because here, 3/4, for example, you've just got one solution there. The other solution would take you beyond pi, which is why, if you think about it, I've not looked at any other answers. These are the only ones that are in our required domain. I'm hoping you found that as fun as I did, and thank you for tuning in. Okay, I'll see you again soon. Take it easy. Bye.